All right, let's dive into something I find absolutely fascinating. How do you go from a simple chatbot to a truly intelligent AI? One that can actually do things. We're going to pull back the curtain and see exactly how these incredible systems are built.
Have you ever talked to an AI and just thought, this is clever, but it's not really smart? Well, you're not wrong. There's this huge gap between just spitting out text and actually reasoning, remembering things, and acting in the world. So how on earth do developers build that bridge? Well, on one side, you've got your basic chatbot. Think of it as just the core large language model, or LLM. It's a one-and-done kind of deal. It has no idea who you are from one sentence to the next, and it's totally cut off from the real world. But on the other side, you have a true AI system. It has memory, it has skills, it can actually use tools. The real magic is figuring out how we give that brilliant base model all those extra abilities.
It all starts with understanding the main problem. The best way to think about a standard LLM is like a brilliant brain, just trapped in a jar. It knows a ton of stuff, but it has no arms, no legs, and absolutely no memory of what you just told it 5 seconds ago. The fancy terms for this are stateless and disconnected. Stateless just means it has zero memory of past events. Every single thing you say is a fresh start. And disconnected means it can't check the weather, look something up online, or even use a calculator. It only knows what it was trained on. Our job then is to break it out of that jar. So, the very first tool we grab to do this is something called a chain. This is how we give the AI a structured, repeatable process to follow. It's the key to moving from just single answers to actually completing multi-step tasks. And a chain is, well, it's exactly what it sounds like. It's a sequence of steps, all linked together. Honestly, the best analogy is an assembly line for the AI. Instead of trying to get it to do some huge, complicated thing with one giant prompt, we break it down into smaller, bite-sized tasks. The output of one step just becomes the input for the next. Let me show you what I mean. Let's say we want the AI to write a story. Our input is pretty simple, a story about a girl who lost her mother. Now, the very first link in our chain has just one job: come up with a title. And boom, it gives us Whispers of Loss.
But here's the cool part. That title, Whispers of Loss, doesn't just disappear. It gets passed down the assembly line to the next link. And that link has a totally new job. Use the title to describe the main character. You can see how the context is building, right? Step by step. And finally, the third link takes both the title and the character description to write a full story summary. By breaking the task down like this, we get a way more structured, way more coherent result than if we just yelled, "Write a story," all at once. We've created a reliable, repeatable workflow.
Okay, so our AI can now follow a recipe. That's a huge step, but it still has the memory of a goldfish. It forgets everything the second the task is done. And this creates a whole other set of problems. Let's just try to have a simple conversation and see what happens. So I'll say, "Hi, my name is Martin. What is 1 plus 1? And the AI comes back perfectly. "Hello, Martin. The answer to 1 plus 1 is 2. Okay, great. It seems to know my name. Everything's working." But then, in the very next message, I ask the most obvious follow-up question you can imagine. And there it is, complete amnesia. The AI has absolutely no clue what we were just talking about. This is that stateless problem in action, and it's what makes having a real conversation with a basic model feel so impossible. So what's the fix? Well, pretty simply, we give it a memory. The concept here is actually super straightforward. It's like giving that brain in a jar a little notepad. After every single interaction, we jot down what was said. And before the next one, we just let the AI read its notes. Now, there isn't one perfect type of memory. It's all about trade-offs. You could remember every single word perfectly, but that gets really long and slow. Or you could just remember the last few messages, which is faster, but, well, it's forgetful. So developers have to pick the right kind of memory for the job. Okay, so our AI can follow instructions, and it can remember things. We've built a pretty solid conversationalist. But now it's time for the final, and honestly, the most powerful piece of this whole puzzle: agents. This is how we give the AI its superpowers and finally let it out of the jar for good. An agent completely changes the game. It turns the LLM from a text generator into a reasoning engine. It gives the AI this utility belt, packed with tools, a search engine, a calculator, anything you can imagine, and it gives it the intelligence to decide which tool to use and when.
The LLM isn't just answering questions anymore. It's a problem solver that can actually take action.
And the engine that drives most agents is this really elegant framework called REACT. It just stands for reason and act. It's a simple loop, but it is incredibly powerful. It lets the LLM think, act, and then learn from whatever happened. Here's how the cycle works. First, the AI has a thought. It literally writes out its inner monologue, like, okay, the user wants a price, so I need to search the web. Second, it takes an action. It picks a tool off its utility belt. And third, it makes an observation. It looks at the result of that action and then decides what to do next, starting that loop all over again.
Let's see it in action. Say we ask for the price of a MacBook Pro, but in euros. The agent's first thought is, okay, I need to find the current price of a MacBook Pro in US dollars first. So its action is obvious: use the search tool. The search tool comes back with a result, and that becomes the agent's observation. The price is $2,249. Perfect. But we're not done, right? The user asked for euros. So the loop starts over. The agent has a brand new thought. Now I need to convert this price to EUR. It reasons that search won't help here. It needs a different tool. So its next action is to use the calculator. It's thinking and acting, step by step, to solve a problem it couldn't have handled before. And that's how it's done. What's so amazing is that we haven't changed the core LLM at all. Not one bit. Instead, we've built this whole sophisticated system around it, piece by piece, to just completely overcome its natural weaknesses. So let's just recap our building blocks. We start with the LLM, that's our core brain. Then we give it a structured workflow using chains. We add context and conversation history with memory, and finally, we give it superpowers with agents and their tools, letting it actually act in the real world. Each piece builds on the last, creating something way more powerful than the sum of its parts. This is how modern AI systems get so smart. They're not just one big model. They're a clever combination of all these different parts working together, which of course leads to the big question, now that we can build an AI that can remember, reason, and truly act, what are the problems we're going to solve next?